All right. Hello, everyone. Today we're going to be talking about templates in C++. What are they and why are they useful? So let's talk about first using templates because it's a little simpler than creating our own. So a good way to bring in something with templates is to include vector. So what is vector? It's effectively a continuous array. So I can say std : vector, but now I have to describe what I'm going to put in the vector. This is the same thing as the type of the array. I do this in these what are called angle brackets. So inside of here, I might want to store ints. So now my vector stores int, and I can call it myvec. The name that we give it doesn't matter. Now, into myvec, I can do push, push back. And we can see that it wants me to give it an int and, or to give it a const int and. So those are our two options. We can't give it anything else because we said it was a vector of int. If we change this to a vector of string, so we're going to need to include string to do that. Now we can give it a string and, or we can give it a const string and. So this template type kind of determines the types that each of the functions of vector are going to deal with. So again, if we tried to push back an int right now, it would be not correct because integers are not strings. So the error that we get is no instance of overloaded function that takes string will work with an int. So what we need to do is we need to give it a string. So we could do this, for instance, and it's more likely to work. So that is how to use templates. Let's talk now about how to write them. So in CSCE 121, you learned whenever you're creating a class, you want to create a CPP file and an H file. So let's, for instance, create a class called A. So I'll have a.cpp and I'll have a.h. In a.h, we needed to do header guards. Header guards mean that we can't include the file multiple times. So we'll say if we have not included A yet, we'll remark that we have now included A and then not ever do this again. And this will define that there's going to be a thing called A, and it's got some properties. Let's say it has a constructor. So we'll go here and we'll create an A constructor. Well, a.cpp will include a.h, and then it will say, let's create that A constructor. And, we could tell it what to do. Let's just give it a default constructor. So this is something you've learned in 121. So what we want to do is we want to use templates. So instead of just A, we do template class, or you can say type name, whatever you prefer. T is generally what's used because it stands for type. So now our A can store objects of type T. So what does that look like? Well, here we are in the private variables section where we can store stuff, and let's just store an object called T. So it's called object, it's of type T. So now what our A constructor can do is it can take in a T and it could call it given object. So now what we want to do is we want to go over to the CPP file and we would want to try and fill this in. But the problem is we don't know what T is. A way to fix it is we could try and add template type name here, or class. However, the problem is that the T that we see here is potentially different from the T that we see in the header file. It has to do with the way C++ combines headers and CPP files. Long story short, whenever you're dealing with templated classes, you have to do all of your work in the header file. There is no CPP file. So let's delete a.cpp because we're not going to use it. We're only going to do work in a.h. So now if we want to write this constructor, we have to write it here in the header file. And if we want to use our A class, we can include A in our main. So now I can create an A, for instance, call it my A, and we can provide, based on that function that we've created here, a template. Now the problem is it's got to be A with a type. So let's say int. So now it wants an int. And if we look at our A, given object. So this is the int that we're supposed to pass, called given object. So, I could say 1, for instance, and it would be okay because 1 counts as given object. But now what we need to do is we need to assign given object to object. So there's a few ways to do this. A simple way is to say object equals given object, like this. This is generally not the way that we do things in C++. In C++, it's preferable to use what's called a list initializer. So you do a colon after your constructor. This only works for constructors. And what you do is you name the object of your class, so object, and then you can do curly braces or parentheses, and then you name the object that you're assigning, so given object. And then you write the curly braces for the function. Now this function doesn't need to do anything because it's already assigned given object to object. And let's now create a getter. So a getter works a little something like this. We're going to return a const t reference, and we'll call it get object. Now this function, because it returns a const reference, means that we won't be able to change obj. So calling this function cannot result in changing the class, changing its data. If that happens, we can put the word const at the end of the function name. That means the function is const qualified. We're going to want to do this for some functions in vector, particularly some getters. And all this function needs to do is it needs to return object. Now, we could want to modify object, so let's create another get object that does not return a const reference. It just returns a reference. So this one, because we could change it, cannot be const qualified. So now we have our two different get object functions, and we can go to main, and I can say mya.getObject equals 2. And now I can print out mya.getObject is, and we would expect it to be 2, because initially it was 1, then we set it to 2. In fact, I'll add this print line up here as well, so that we can see that it should be initially 1 and then it's 2. So if we try and run this code, we can see that we get mya.getObject1, mya.getObject2, because we've changed the value. Now, what we could do is we could say, have a function up here. It returns void, and the function's name doesn't matter, so I'm going to do foo. It's just kind of a little made-up word programmers use whenever they don't want to name something. And let's say it takes a const a reference. We don't care what type the a is, so it could be of any type a. And we'll call it a in lowercase. And what this function's going to do is it's simply going to print out a's object. So there's nothing wrong here, because getObject is const qualified. There's a version of getObject that has const here. If we didn't have one that had const here, then trying to invoke getObject on a const a reference like this would not be permitted, and it would fail. So let's call this a.getObject, and now we can just say foo my a in both cases, which is very nice. Let's create another function that looks very similar. Another made-up word for the name. We'll call it bar. And what bar is going to do is it's going to change the value. So mya.getObject is going to be equal to 3. So let's try and build this code. So we can see right away that the code doesn't build and that we get a little error here. So let's take a look at what happened. MyA was not declared in this scope. Well, that's one issue. Instead of MyA, it needs to be A, because that's what we called it here. So let's now build again. So it seems like the code built just fine, and we can run it, but that's because it ignored the bar function. the bar function's actually not allowed. Let's try it. Bar my a right here. And then we'll do another foo my a afterwards because we expect the bar one will change the value to 3. So let's see, if the value is 3. So we try to build it, and sure enough, we now have an error. So the error here says assignment of read-only location. So what's going on is whenever we have the const a, it can only use the const function. So it uses this one. It ignores this function. Well, this is a const t reference. Since it's const, we can't change it. So whenever we try and change it here, it's not permitted, and the code does not run correctly. So the bar function can't exist in this way. A way to fix it, by the way, would be to make it so that it just takes an a reference, not a const a reference, and now the code builds and runs just fine. So there we go. That's a brief introduction to templates and const qualifiedness. As you can see, with templates, you can return reference types, you can return pointer types, you can return all sorts of things like that. So yeah, hopefully that clarifies some things about templates. They're basically ways to generalize types. In this case, we were only using ints, but we could just as easily have done a template with char, long, int pointer, a pointer, void pointer, string, vector of int. You can do templates with any kind of internal type that you want. I stopped including vectors, so this is now not allowed, but you got templates let you do a lot of generic kind of programming, and that's why it's called generic programming, because the types of your class can vary dramatically. When it comes to the first assignment, we want you to check out the reference page. So let's go to the page for the first assignment. github.tamu.edu, CSCE 221, assignment-vector.git. So here's the first assignment for assignment vector. It explains a lot of what you need to write, and importantly, it links to a lot of the functions. So let's say you're not so clear on what the clear function does. You can click the link, and it brings you to the reference page. Now, there's a lot of information on the page, but you want to read whatever is at the top. So it erases all the elements in the container. After this, size returns 0. Invalidates any references, pointers, and things like that. Leaves the capacity of the vector unchanged. So what this does is the data in the vector is effectively unchanged. The capacity does not change. It just sets the size to 0. So that's all the clear function has to do. You can see the capacity is unchanged. And they even have a little print for their vector here, which sets the beginning and end iterators to the beginning and end of the size, which is correct. But what we could do is we could modify this code, and we could tell it we actually want to print from the beginning to the end plus 3, so that we can print the 3 elements. We can see that they're still there. So the 1, 2, 3 are still there. The capacity is still 3. All clear does is it sets the size to 0. So it's a very simple function. That's how a lot of these work. You can go to the reference page and read about them. And you can also go to the bottom here and you can play around with the code that they provide. You click run this code and you can make changes and run it live on the browser, which is really nice. So yeah, hopefully that explains a little bit more how templates work and how you can work on the vector assignment. I'll be putting out another video shortly explaining the rule of 5, which has to do with move semantics, move assignment operator, and move constructor. Thank you so much for watching, and I look forward to seeing you in the next video.